distinguished guests, ladies and gentlemen, welcome to the Intelligent Robotics and Automation panel of the Science for Life Symposium. The event will be delivered many things that you can share together. Your presence means a lot to us. Thank you very much for coming. Distinguished guests, ladies and gentlemen, VinFuture is prestigious global science and technology award proudly originating from Vietnam. And the topics we'll explore today are essential for advancing the scientific progress as well as advancing the humankind, an implication profoundly. Ladies and gentlemen, Vietnam is emerging as a committed contributor to global science driven by a rapidly expanding ecosystem in intelligent robotics and automation. Advances in robotic technologies are enabling the development of sophisticated humanoid robots capable of performing complex tasks from industrial operations to healthcare assistance. Automation solutions are transforming manufacturing, logistics, and daily life, improving efficiency, safety, and productivity across sectors. Meanwhile, the integration of vision language models in robotic systems is enhancing robots' ability to understand and interact with their environment in more intuitive and human-like ways to promote scientific and technological knowledge to the public, as well as connect generations of young scientists, inventors, and entrepreneurs with globally inventors for potential partnerships. So today's event is being held with the participation of distinguished speakers who have excellent expertise and experience in the field of intelligent robotics and automation. Joining us today in the symposium, we would love to welcome our distinguished guests. Ladies and gentlemen, it is our honor to welcome Dr. Lê Thái Hà, Managing Director of VinFuture Foundation. Thank you so much for coming. It is our honor to welcome Professor Ngoc-Minh, member of the VinFuture Prize Pre-Screening Committee, University of Illinois at Urbana, Champaign, USA, and VinUniversity, Vietnam. Distinguished guests, ladies and gentlemen, and now please kindly direct your attention to the main screen. Let's take a moment to introduce the topics today and also get acquainted with our chair and distinguished speakers through a brief video. Video, please.
The world is entering an era in which the boundary between humans and machines is increasingly blurred, where automation, electronics, and robotics are not only transforming the way we work, but also reshaping the way we live. According to the International Federation of Robotics, IFR, by 2023, more than 4.28 million industrial robots were operating worldwide, with over 500,000 new units installed each year. The service robotics market is projected to exceed $100 billion by the end of this decade, highlighting its vast potential across manufacturing, services, healthcare, and education. However, as robots become more prevalent in hospitals, restaurants, and households, even minor errors in algorithms or sensors could directly impact human health and safety. Issues of reliability, transparency, and ethical standards have therefore become increasingly critical. To promote scientific dialogue and foster sustainable development in the age of automation, the VinFuture Foundation is honored to present the Symposium on Intelligent Robotics and Automation, where leading scientists will share technological breakthroughs and human-centered approaches, paving the way for an era of intelligent collaboration between humans and machines. The chair of the symposium is Professor Ngoc-Minh, University of Illinois at Urbana, Champaign, USA, and VinUniversity, Vietnam, member of the VinFuture Prize Pre-Screening Committee, and former Vice Editor-in-Chief of the top-tier journal IEEE Transactions on Image Processing. The symposium is honored to welcome distinguished international scientists in the fields of automation and robotics, including Professor Ho Young Kim, Seoul National University, South Korea, a world-leading expert in fluid mechanics and soft materials, and Fellow of the American Physical Society, APS. Professor Kurt Kremer, Director Emeritus of the Max Planck Institute for Polymer Research, Germany, member of the German National Academy of Sciences Leopoldina, and recipient of the APS Polymer Physics Prize and the Staudinger Medal 2024. Dr. Nguyen, University of Southern California, USA, Chairman and Chief Scientific Officer of VinMotion Vietnam, and recipient of the Charles Lee Powell Foundation Faculty Research Award 2020. Professor Tan Yap Peng, Provost of VinUniversity, Vietnam, former Deputy Dean and Interim Dean of the College of Engineering, Nanyang Technological University, Singapore, and Fellow of the Institute of Electrical and Electronics Engineers. In alignment with the aspiration rising and thriving of the 2025 VinFuture SciTech Week, the symposium will embody the spirit of innovation and humanity, where science and technology converge to shape a future of intelligent collaboration between humans and machines.
I'm so sorry, the technical problem. Thank you so much for your patience, ladies and gentlemen. And now it is time for us to welcome to the stage Professor Ngoc-Minh, the Thomas and Margaret Huang Endowed Professor with the Department of Electrical and Computer Engineering, University of Illinois at Urbana, Champaign, and Honorary Vice Provost at VinUniversity, and also he's the chair of today's symposium to deliver the introductory speech for our topic today, Intelligent Robotics and Automation. Please welcome Professor to the stage. The stage is yours.
Good morning, everyone. Let's try it again. Good morning. Thank you. Well, today we're going to talk about robotics and automations, but I think we need to demonstrate our human spirit and enthusiasms. That's something uniquely, and I think we always need to stay at the boss, right? I'm very delighted that we was able to put together a fantastic panel of speakers today. You're going to hear from the leading experts a number of advances from materials to manipulating to AI that all aim to make robots to be more intuitive, more friendly, interacting safer with humans, and become more and more useful in a wide range of tasks. Our speakers also come from a wide range of disciplines and countries, from Europe, US, Asia, Vietnam, and also you can see that come from different departments, different disciplines, which is truly the spirit of research and development in robotics these days. So without any further ado, I want to proceed with our four speakers. Each going to give 7 minutes each about these key advances in the area. And I think all addressing the questions, what could be a potential breakthrough in the incoming years in robotics? And then we would engage with our audience, and I would welcome everyone to start thinking about the questions. What should be the key things that collectively we should think about as we're going to advance, adopt, and deploy these robots in our everyday life. Okay, so first I think I'm ready to now invite our first speaker, Professor Kurt Kremer, from Max Planck Institute, going to talk about soft material for robotics applications.
Yeah, thank you very much. Good morning to everybody. It's a great pleasure and honor to be here to participate in this symposium and in this whole event. I already learned a lot, and I'm very much looking forward to learn even more. Having said this, I'm not a robotics expert. I'm by training a theoretical physicist working on soft matter for many, many years. But I think from that side we can contribute, at least from the materials side, to a certain extent. So the other day we heard, for instance, already a lot about AI and the opportunities and threats of AI and so on. But in the end, we live in a materials world, so there's a materials basis for that. And what I'm going to talk about today is about aspects of soft matter in this context. So what I would like to do is I would like to go through a few points where soft matter might play, or polymers might play a role for applications. And I will go from kind of obvious applications all the way through more and more advanced applications. So let's start with a kind of obvious one. Well, if I think of typical soft matter materials or polymeric materials, of course, they are fantastic as lightweight structural material. That's a standard application. We don't have to talk about that. The properties are adjustable, easily adjustable from hard to soft, and so on. They can easily be combined with sensor elements. There are many design options, and they are simple to process. In most cases, you can simply use die casting or extrusion processes to get them. And they are cheap and basic and abundant. Of course, there are some improvements which we are working on, which are important, like improved mechanical strength. One can go to ultra-high molecular weight materials to exceed even the strength of steel easily nowadays. And of course, we have to work on the biodegradability of these systems. And here on the right-hand side, you see a few examples of applications for these kind of materials. Now let's go one step further, namely to smart or responsive systems. And the example which I show here is polynipalm, a kind of classical example, and where the typical monomer is kind of amphiphilic. It's hydrophobic and hydrophilic. And when you now take this polymer, which you see there on the left-hand side, into water, it's swollen. And when you add a little bit of alcohol, it collapses, as you see there on this curve. So the solution becomes turbid, and you add more alcohol, it expands again. So it is responsive to a certain stimulus, which in that case is addition of small amounts of alcohol. And what is important here is you see that this collapse transition is in a very tiny window, so it's very fast and very large. And that, of course, you can use for many applications if you want, for instance, to steer valves and or to have mechanical action. And in this respect, there are many, many different stimuli, as you see on the right-hand side, not only the addition of another solvent, it can be pressure, it can be temperature, it can be pH, it can be an electric field, and so on and so on. So there are many means of manipulating these kind of systems that they react in a very sensitive and fast way. This is one aspect. And then, because these are chain molecules, which are large and can collapse, there's another aspect, which is the architecture aspect. So you can combine them into gels or into brushes, and so that you have complicated structural organizations which then can perform very specific mechanical tasks. And here are two examples of that. On the left-hand side, you see a polymeric brush, which on the one hand, the green one, is directly reacts to temperature. You can heat it a little bit up or cool it down, and it swells and expands. And on the right-hand side of this brush, it's the red one, for instance, is very sensitive to pH. You change pH a little bit, and again, it collapses and expands. And now you can make block copolymers, in that case, red and green, and you can combine that so that it gets very complex again, mechanical response due to delicate changes in specific stimuli. And another example here is on the right-hand side, where you have a dielectric fluid captured in a gel, which is very flexible and can be expanded or change the shape hundreds of thousands of times. And what you have in the middle are two plates which you can put a voltage on. And when you put that voltage on, these plates attract each other, so the liquid is pushed to the side, and that means this volume, the shape of the volume with the dielectric liquid has to change. And by that you can make a mechanical actuator as well. And where you see on the lower right corner, you see a kind of artificial type of hand. And by the adjustment of the electrical field, the volume of these objects, you can make very sensitive gripping agents which are able to really delicately touch and get to grab things, for instance, which you can directly use in robotics nowadays. When we go on, we can add to this kind of mechanical responsiveness of a system, we can add electronic features. So, for instance, there are many polymers which can conduct electricity. They have many polymers with a strong dielectric constant and so on. And if you compare that to typical silicon electronics, of course, they are not as fast, they are not as small, but on the other hand, they are much cheaper. And you can use them in many different ways, as shown there. But and they are kind of easy to process as well. And they are essentially carbon-based. Carbon plus a little bit of hydrogen, oxygen, nitrogen, sulfur or so, but no rare earths, which means it makes it very interesting for applications if you are not if you don't want to depend on rare earths. Here are a few examples where these systems are already used. You all know this organic photovoltaics on backpacks or so. You can use organic light-emitting diodes, and our chairman here of the whole activity, of course, is one of the world experts, or if not the world expert, when it comes to polymer electronics, and you can make organic field transistors from that. Here are a few examples which you can buy readily. If you go to an electronics supermarket, you can buy OLED, organic light-emitting diode screens, or you have this foldable cell phone, which is also based on organic dielectric diodes. And a specific one which I like most very much are little graphene stripes. If you have graphene, it doesn't have a band gap, so you cannot use it for transistors or so. But when you have a well-defined stripe, you can adjust the band gap by the width of a stripe and by the decoration of a stripe. And that gives enormous versatility in making new organic electronic devices. Here's an example of a field effect transistor which reaches an on-off ratio of 10 to the 5, which is as good as for any other standard organic electronic device. So in principle, one is there already for many applications and is competitive to standard hard matter electronics. Now, so we started from a very simple commodity, which is structural material. Then we had the stimuli responsive material. Now we added the electronic properties. And if we combine all that, and this is the kind of future which is emerging, you are arriving at organic neuromorphic electronics. So you combine electronic properties with soft matter responsiveness properties, and then you can create materials which adjust themselves, which learn to build, let's say, an electronic structure or an electronic function as a response to stimuli from the outside or the request what you have. So they can learn by this what they should do. This is something which is emerging, and I think this is something which probably will have a bright future in the coming years. So summarizing and coming back to what I've said at the beginning, we started out with the standard commodity materials point of view. We have something which you can put something in or so. When we added the smartness or responsiveness of the systems to react to certain stimuli in a very delicate way, then one can add on top of that, for instance, electronic properties, so that one can make electronic devices out of polymers together with the mechanical responsiveness, and eventually this will kind of merge into what is nowadays called neuromorphic computing, which has many more options than standard hard matter electronics. So to summarize, I think in one sentence, soft matter offers, I think, unique opportunities to make robots more versatile and environmentally more friendly, no rare earths, simple processing, and possibly even cheaper. Thank you very much.
Thank you very much, Professor Kurt Kramer, for your informative presentation. Thank you. Thank you so much. Could you please kindly return to your seat so that we can follow up to the next part with the next presentation of our distinguished speakers. And now, moving next to our second lecture keynote, please welcome to the stage Professor Ho Young Kim, Professor of Mechanical Engineering of Seoul National University, South Korea, to deliver the second presentation today on manipulating soft materials for advanced automation. So, Professor, it's your time.
Thank you for the introduction. I'm Ho Young Kim from Seoul National University. Today, I'd like to introduce to you one of the most difficult problems that modern robotics and automation technology is facing, manipulating soft materials for advanced automation. Soft materials are ubiquitous everywhere around us. At homes, you deal with soft fabrics when you do laundry, and in the kitchen, you deal with soft food, and also plastic bags you always carry. Also in factories, there are a lot of soft materials, including wires, fabrics, also even medical stuffs. Actually, either when you're in the factory or in kitchen or in any household work, you deal with the same problem of handling soft materials, only in different settings. Conventionally, machines or robots have preferred rigid objects. When you have rigid objects, the state of the material is well defined. You can easily describe and estimate the 6 degree of freedom state of the material. For example, when you have an assembly line of the automobile, you pick up a very rigid door, and you can easily design the path of your robot arm to assemble your automobile door to the main frame. But when you deal with the software objects, then the degree of the difficulty of handling this material is enormous. So for example, when you want to pick up a t-shirt, depending on where you pick up your t-shirt, the shape changes forever. And also, the weight of the t-shirt will change depending on how high you lift up this t-shirt. Also, it wrinkles, it folds. So the number of the parameters that you need to describe the motion and also the geometry of t-shirt is enormous, almost infinite. So let me show you an example. I think you have seen a lot of humanoids doing folding of the laundry. It looks very interesting, also very easy for the humanoids. But the real problem or real life is not very simple. So this is one example. So you have the t-shirt, and now you see something strange. Usually, there are 2 sleeves, right? But in your real life, sometimes one sleeve is folded inside. And would today's humanoid be able to figure out that one sleeve is inside? And would it be able to push its hand into this sleeve all the way to the end? And then it can put it out, just like human? This is notoriously difficult for modern robots. So this is paradoxical. Humanoids or AI are very good at solving partial differential equations, and it can memorize the whole encyclopedia. But this kind of simple household work is enormously difficult for modern humanoids or AI. So this is one of the most important paradoxes that common conventional robotics are facing these days. So this talk is rather about the question than answer. And let me show you some of the advances that I made in my lab in terms of the manipulating soft materials. So I have focused on how to pick up a fabric one by one, okay? So here, we mimicked the two fingers that are picking up a fabric. So in factory, it's very important that you pick up only one sheet at a time from the pile of the fabric. So this is the success case. But depending on how hard you pick up, how hard you push your pile of the sheet, you can either pick up only, you can either no fabric, or you may pick up 2 or 3 fabrics. Then it's a failure in the manufacturing line. So we have come up with a new pickup system where we use the membrane instead of the 2 pickup fingers. So if you use the membrane, okay, then you can pick up, in addition to the fabric, you can also peel out the biological object like the orange, and also combining this with the rigid robots, you can pick up the whole fabric in a stable manner, and then you can transport it to another direction. Using this kind of pickup system, we can make a real machine that can be used in garment manufacturing industry. So this is called numbering process. This is very, very important and fundamental in garment manufacturing process. And this has been done by the human hand always. Now we have made a new machine which can do this numbering process automatically. So you have to repeat the numbering and also stamping repeatedly, and there should be no mistake in this process, because this numbering. So if if you are picking up 2 or no fabrics, then your numbering is all screwed up, and your subsequent manufacturing processes are all failure. So this is very, very important, and it's important that your soft material fabrication or soft material handling process should be of no failure or no flaws, okay? So here are the challenges that you have to meet to make this kind of soft material handling possible. So one is the perception, how we can perceive or sense the state of the soft material. And we need the hands, very precise hands, to be very dexterous in handling those materials. And also we need the control skills. So there are a lot of unknown parameters and vague material description, but still you have to be able to control your robot arm. And also this should be scalable. You may be able to make a very, very delicate, expensive material or expensive control system to handle the soft materials. But if you want to devise this into a company or into a factory or in our household, then the technology should be scaled up. So they should be very cheap and environmentally friendly. Okay? So with this, I like to emphasize that soft material handling is the key that unlocks robots for real-life tasks. So I'd like to introduce to you and invite you to this endless journey, but which is very, very important for the robots to be used in our houses and also many, many kinds of factories as well. Thank you very much.
Thank you very much, Professor Ho Young Kim, for your insightful speech and especially the vivid demonstration through the video clip and also the t-shirt that you bring on stage right now. Thank you very much, ladies and gentlemen. And now it is time for us to come to the third keynote lecture. And let us welcome to the stage Professor Tan Yap Peng, Provost of VinUniversity, Vietnam, with the lecture on robot interaction with vision language models. Welcome, sir.
Good morning. Of course, we are on robotics today. So although we have seen many robots in different industries, to your surprise, to let them work like this is amazingly challenging. Right? And you can see some of these robots now have been deployed to deliver goods in Amazon, the latest Blue Jay, which try to help those human workers to speed up the delivery process. And also in Starbucks, now you have this service robot to deliver coffee to your client. And this is the so-called the largest sector in robot now. It actually occupy about 50% market share. And we also have cobot, which you meant to work with humans so that they can collaborate with each other. Robot can understand the human intent, react to it accordingly, and which is surprisingly challenging. And of course, more recently, we have these humanoid robots. I think the next speaker is going to talk about that. The reason we want to have this is they can work in the human environments and collaborate with us. And it's predicted that by 2050, the world is going to see at least 1 billion of robots stay together with us. So how are we going to make them work as we want and work together so that we are safe and we can collaborate to produce more results? This is challenging. Of course, as you can see, most of these robots, they are programmed to address a single task. Right? If you want to get the robot to do other things like washing laundry for you, it will not be possible at today's technologies. But progress has been made, learning from the large language model, and now we are trying to impart the knowledge based on a lot of video, and so that they can work like the ChatGPT that you are familiar with. They have the general knowledge, can do many, many language tasks. However, to move from the language to the vision and then to the action, which is a long journey to go, right? From the robot, you want the robot can see the world, can reason, can listen to the instruction, and this is still the current active research area. So the idea is, how can we move from a task-specific robot to a general-purpose robot, which allow to understand the world, understand the new environment, and then to solve multiple tasks. And current so-called technology, and based on some of the recent advances, and they have demonstrated some capability, but not, of course, to the extent that human can do. And for example, now we can have a model like the one from the Physical Intelligence Pi 0 that can take the image and video input, listen to the instruction, and output with the action which allow to control different types of robots. However, to do very, very specific tasks, and which you still require a lot of fine-tuning and expert demonstration. Here are some examples, and this is what the, okay, let me see, they should have video playing. Okay, sorry. Somehow the video are not working here, sorry about that. But what is showing here is the robot with the general purpose robot learning. It can clean a table like the one on your left-hand top corner. It can also make a box. It can also do laundry, and it can also folding clothes like what the previous speaker said. And now these are the tasks they can do. But it actually comes with a lot of training, a lot of fine-tuning. And if the task is very complicated, and the robot will not be able to complete the task successfully, okay? And the reason is the robot can only pre-train with all these so-called video and then program inside the parameters, right? They doesn't have the human capability like your memory, right? So for example, when we actually try to do multitask, and some of the things that we do not need to use the brain to think, like we are walking, right? So you just retrieve from your episodic so-called memory that you can actually control the environment. So this is what we want to impart on the robot that can do something like this. Some of the recent work by my student and the research collaborator, we have come up with this idea of how you can encode the expert demonstration into chunks of memory inside the so-called memory library. So when the robot is put in action, it will try to remember what have been the action that which can help with a particular task. And from there, it tries to retrieve the memory, applying some kind of a short prompt kind of approach, allow the robots to actually use the kind of expert memory to carry out the task. And which has been shown to be quite successful. Unfortunately, the video cannot be played here. But what we demonstrate is for a long horizon task, and the robot can complete the whole instruction action without any so-called error compared to the existing so-called physical intelligence demonstration. Okay, I don't think I can get it work. But of course, it's still a long journey to go, and there are still many, many problems that we have to address. right? Rather than a specific so-called task that we have in mind, how can we make the robot behave like human, right? It can deal with dynamic environments. It can so-called deal with those imperfect or error condition. How can they actually correct themselves in order to address those unseen environments? And how do you make them like human, the kind of so-called skill or dexterity? And the hands itself have many high degree of freedoms. Currently, robot cannot really have the kind of freedom to do anything that we want them to do like humans. And how can we actually make them work with humans in a so-called society like us we live today? And also the power efficiency and longer operating time. And these are all the challenges that we have to program the robot. For example, if you want to have a GPU inside a robot, which is very power consuming, and the robot cannot last for very long, right? And how do we maintain it? And you can even do the kind of cell diagnosis kind of maintenance. And how do we make sure that it's safe, it's ethical, it's reliable? And also when the robots are everywhere in the industry, how can we live with them? How can a human control them and work with them in this environment? All these are all the challenges that we are facing for the next so-called perhaps 30 to 50 years. Thank you very much.
Thank you very much, Professor Tan Yapeng, for your insightful speech and presentation. Ladies and gentlemen, and now it's time for us to move to the final keynote lecture. Please welcome to the stage Dr. Ngoc-Minh, Assistant Professor of Aerospace and Mechanical Engineering at the University of Southern California, USA, and Chief Specific Officer at VinMotion, a pioneering humanoid robotics company founded by Vin Group, on the lecture, Humanoid Robots and Physical Intelligence, Challenges and Opportunities. So the stage is yours. Thank you.
Okay. Good morning, everybody. It's my pleasure to be here today. Normally, I would love to talk about research, paper, equations, and show you a lot of exciting videos about robots. But due to the interest of time, as Professor Ming-Do gave me the requirement that I need to present it in 7 minutes, right? So today, I would like to talk very briefly and highly overview about some challenges and opportunity about humanoid robots. And I will also talk about, some kind of methods that we are trying to address these challenges here at VinMotion. And later on, I would love to also talk very briefly about how Vietnam could be a very big player in this emerging field. Okay, so before talking about physical AI and also humanoid robots, let me talk briefly about digital AI. So as you can see, in 2024, the market size of digital AI or some like generative AI platform like ChatGPT, in general could go up to $200 billion, right? And by 2030, it's expected that it could go up to $800 billion. So the impact of digital AI is huge. There's no question about that. So and let me try to clarify a little bit here why I use the word digital AI, because generative AI in general and digital AI here, we train everything inside a computer, we verify everything inside a computer, and we test everything inside a computer. So there are a lot of challenges in this domain, but if we move to the next trend about physical AI and robotics, we don't have such luxury of doing everything inside a computer. So we need to move to the physical environment where the data is very limited. Okay, so however, the world is trying to shift the attention to a new field of physical AI, or in a more specific perspective, general purpose robotics. So the question is why people think that physical AI and humanoid robotics in general could have a great potential in our life. So I think the main reason behind this is that because with physical AI, we can have an AI agent that can not only think, but can also act and interact with humans and perform many meaningful tasks in our daily life. So that is the reason why people predicted that in the next 10 years, the market cap for physical AI and humanoid robot can go up to $10 trillion. Okay, 10 trillions, not billion. But So I know that this is still a prediction, but I still believe that there are a lot of exciting opportunity and challenge that we can address in this emerging domain. Okay, so as you see the economic, I think the mathematical for the economic problem is quite clear, but the question is how can we get there, right? I think there are a lot of challenge for us to tackle this. But the good thing that if we can make it happen, I think the economic problem is quite clear and it's very exciting for us to tackle this. For this problem, I think it's not only, I think for this kind of equation here, many people think that, okay, this may be some kind of prediction for the US market, Europe market, for example. But I think this kind of labor shortage problem is also come from across different countries as well. So in the future, I think this is also a very challenging problem for many different countries. Okay. However, the main challenge for physical AI is this kind of chicken and egg problem, right? So in order to have a good physical AI, different from digital AI, we can train everything inside a computer. For physical AI, in addition to some data that we can generate in simulation, it's very powerful. But to really make physical AI to become very useful and practical and accurate as well, we really need real-world data, right? However, in order to have a real-world data, we need to have real robot to deploy in a real-world application. But ironically, in order to get robot to be able to perform some useful tasks, you need to have a reliable physical AI agent. So it's more like an infinite loop or a chicken and egg problem that you really need to get stuck there. So at VinMotion, in order to try to tackle the challenge, we try to focus on a pretty unique approach of having human-in-the-loop operation. Because I think, in my opinion, in order to have a good AI solution, maybe the most effective way that you need to get the robot out there, collecting data, and keep improving over time, right? We don't expect that the robot, when you send a robot out there, it can get the job done 100%. But let's say if you can get it done 80%, how can you make sure that it's safe enough for you to get the operation? So the method that we have here that, okay, instead of trying to work everything inside the lab, inside the company, and in hope that we can help the robot to be able to perform the task that we want 100%, okay? We need to go fast, we need to deploy it, and then we learn from mistake. However, in order to learn from that, we need to, I think in the first step, it's very important to have human in the loop, because safety is very important for deployment, and having human in the loop is very important for us to keep the deployment going. And the second thing that is also very important that I want to highlight here, as you see, for ChatGPT to be successful, human reference feedback is also very important to keep AI improving over time. And in our perspective here, we also want to have human here. It's not only the operators, but they also will be the supervisor for the robot, for the AI system, so that it can give suggestion whenever the robot gets stuck in a certain task or different difficult environment, so that we can have improving our AI system over time effectively. So I think with this human-in-the-loop kind of operation system, it may give us a very strong foundation for us to deploy a humanoid robot very fast, very reliable, but it also prepares to be able to scale up humanoid deployment very effectively. So I think that is very important. If we work on humanoid robot, but if you don't be able to scale it up, you will not be able to solve the fundamental problem that you have. Okay, so why Vietnam? So I think this is an exciting time for Vietnam to join this competition, because in robotics and in humanoid robot, I think there's three main different things that we should work together. We need to have very good hardware, we need to have very good software and AI, and we need to have very safe and reliable deployment. And I think Vietnam is in a very rare position that we can do really well in all of these three aspects at the same time. If we compare with some other main players like US or China. So, okay, so to wrap it up, I think in general, there are a lot of exciting opportunities. The opportunity is huge, but the challenge is enormous. So what should we do? I think that's one way that we can do is just keep working on it and hope for a bright future. Thank you.
Thank you so much. Thank you, Dr. Ngoc-Minh, for your hard work and your amazing speech presentation. Thank you. Ladies and gentlemen, so we have been through 4 lecture keynote with 4 distinguished speakers. And before we move to the discussion panel today, please join us to watch a short video clip. It is the recap of VinFuture events that are inspirational talks, the next breakthrough, and the Symposium Global Frontier, Ethics and Safety AI for Humanity. And now let's take a look at the events just 2 days ago. Video, please. Thank you very much for your attention on our journey with the very first event of the VinFuture SciTech Week. Ladies and gentlemen, and now it is time for us to welcome to the stage our chair and the distinguished panelists. Let us welcome to the stage Professor Ngoc-Minh along with Professor Ho Young Kim, Professor Kurt Krimmer, Dr. Quân Nguyen, and as well as Professor Tan Yop Peng. So ladies and gentlemen, please welcome and giving them a warm round of applause for our distinguished panelists. And now it's time for the symposium, today's discussion, and Professor Ngoc-Minh will be the moderator of the symposium. Professor, please. Thank you.
Okay. So maybe I can kick off with the first question. Given what you all have presented, in the next few years, which industry or applications do you see a lot more robots going to be, serving people or interacting with people? Yeah. We're talking about like near future, the next 3 years. Anyone want to?
Okay, let me start. Of course, certainly the manufacturing, it will continue to rely more and more on robots because these are the tasks that humans prefer not to do. But we also need to learn the new skill to control and work together with the robots so they can actually support us to do those work more efficiently and hopefully also faster and cheaper. So these are one of the areas that I think they will continue to grow. Right? I think humanoid robot have potential because they can work in a human environment, right? And like service, help with the elderly, those service industry. I also see there will be a lot of robots. Even now you go to hotel, you see those service robots, right? They deliver your goods and food to your room. And this become more and more common. I think this will continue to grow as well.
Anyone else want to?
Yeah, maybe I can contribute a little bit here. So I think in general, let's say if we can divide it to two different kind of categories, classical robotics and a new emerging physical AI field. So I think both fields will observe kind of significant adoption of robots in the next several years. Because I think with the recent development of VOA, for example, even with some classical solution of robot manipulation, industrial robot, for example, we will also observe some increase in the adoption of those kind of field. Because I think now with VOA, with the development of affordable hardware, many people also working on something what we call micro manufacturing. So I think it's also a very exciting field. I may be biased, but I really hope to have many, many more humanoid robots in the future. Yeah.
And I do want to invite the audience to start thinking about the questions, and we're going to have more time for getting the question from the audience in a very short time. I'd like to, given that you share those robots, automation going to be deployed more and more in our everyday life. The question from the user is how can we ensure the public going to trust and accept these robots, right? And what kind of threat could potentially, of course we would have people to automate, to do many tasks, but job would be lost, right? Or what kind of new jobs we need to be created. So in the high level, where do you think that research and development need to be ensure again the public trust and acceptance of robots and automation in the future?
May I start?
Yes.
So the chair made a very legitimate argument that robot may threat our lives in terms of the job security and also through the interaction between rigid robot and human body, there may be a physical damage to our body. So in terms of the job security, that's ongoing this debate, and I'm not sure whether there we have agreed upon a solution for that. But I think our society will be able to come up with a solution eventually, because a lot of people are aware of this problem, and so that's something we will have to keep debating on and discussing. In terms of the physical damage that robots can do us, in that case, I think really the soft robotics or the soft material covered, the covering the rigid robots will be essential for the taking care of the elderlies or patients or small babies, or even for the household humanoids that will be doing very tedious household work, but still they have to communicate and also physically interact with the family members. So for that case, we really have to consider covering those rigid robots with the soft materials, or we will have to make a new material that can substitute rigid, the current metallic or a rigid plastic material to the more soft material. In that way, you can minimize the risk of damaging human body through impact or collapsing and that kind of thing. That should be accompanied by the endeavors from chemists, material scientists, as well as the computer scientists and also mechanical engineers as well.
Thank you.
May I add directly to this? I think from the soft matter science point of view, so I'm not an expert constructing machines or so, but when you take the soft matter point of view, you can have the standard polymeric materials, but you can also use supramolecular chemistry, and by combining that, you can kind of implement certain limits of strength or action, which physically cannot be overcome by the whole machine. So it will stop by itself automatically. You don't have to program this explicitly. And this gives a kind of safety layer in between, which might be very important for general acceptance.
Yeah, can I contribute? Please. Yeah. Sorry, I think I'm very excited about this question, so I may have a pretty long answer. Yeah, but I think to build trust, I think it's very important for, let's say, a company to build products. So I think a lot about it. And in my opinion, there should be, talking about safety, we may want to talk about three different aspects. The first one is physical safety, right? The second one is data privacy. And the third one is user acceptance. So I think sometimes people get confused between them, but I think there's maybe three different aspects that it's very challenging to address all of them at the same time. So I think for physical safety, as you may know, in the future, we may want to have a robot to safe by design, right? But also safe in the software and AI so that it can interact, move, operate safely around human. For data privacy, is maybe a different topic, but it's very important because let's say in the future, you have humanoid robot carrying a lot of advanced sensor moving around human environments. I think people will care a lot about data privacy when we start deploying humanoid robot at scale, right? The third one I think is also very important is like, in order to allow any application to be scaled, you really need to gradually increase user acceptance. And I think it's also, we think a lot about it because it's affect our design, it's affect our solution, it's affect the design of our algorithms and almost everything. So I think it's a very exciting question that we may want to keep asking us about this almost in the next 10 or 30 years.
Thank you. So I would like to invite questions from the audience. Yes, please.
Yes, may I assist you, Professor Tu Quyên Nguyễn, right?
Yeah, could you, okay.
Thank you very much for really excellent section. I have not heard we talk about advancing robotic. How about the life cycle, end of life cycle, and also in terms of recycling of all of the robotic? Because we want advanced life and science and technology, but we don't want the negative impact to the environment. So could you please comment on that? Thank you.
Yes, the panelist.
Maybe I can start. When it comes to soft matter or polymeric materials, recycling is of course a huge issue. We see all the problems we have with plastics everywhere in the world. But there are two aspects. One is the amount of material used in this context probably is negligible compared to packaging. So I think the first thing we have to take care of is the whole packaging issue, which is in principle simple. It's only a matter of political decision. Here, these kind of materials, they should be developed in a way that they are biodegradable, but there might be a small amount where this simply is not going to be possible. And I know this is not very fashionable, and many people don't like to say it, but I think in the end, these materials can easily be burned. They can be burned in a way that you don't get any poisoning remainders, and it's a kind of intermediate use of oil which anyhow would be burned, and one can even do this from natural resources, so one can do this in a cycle. But of course, this means that compared to the overall amount of plastics which is used in the world, this has to be a small amount. It cannot be like with packaging nowadays. No? As long as it is a small amount, I think one can take care of it like this. If it gets much, much more, we have to do much more as well, and the question is whether these materials then are really the ones to go for.
Another thought on that?
Yes, please.
Yeah. Actually, when you talk about the recycling of the robots or automobiles of these days, the batteries are really big problems, and it is one of the biggest, the hardest problem to recycle. So, batteries might not be, indispensable, but might be indispensable. But one way to, minimize the problem is that you have to reduce the size of the battery, meaning that your robot should be light and very efficient, so that you don't have to use much energy. Ideally, your robot wants to use the renewable energy source like sunlight or the wind or thermal gradient. But eventually, if you need to use electricity, then you will have to use batteries. But you want to make a very light, efficient robot so that your batteries become small. Then you can minimize its impact on the global climate and also over the globe. That's one
Good point.
Thank you very much, Professor Ho Young Kim. So we want to hear some more questions from our audience. Yes, please.
Yes, there's a question in front here, please.
Thank you. I think we have excellent panels with all the experts in the different fields of robotics. And thank you for your talks anyway. I have a simple dream, a simple question to you all. Can humanoid robots have muscles like human beings? If it is possible, when can we do that? The muscles, the elastic muscle, like the human being. These are simple things, right? Okay. Is it possible?
Yeah, the question is about this soft, elastic muscles.
The muscle like human being, right?
Yes.
So that also perform actions, expressions, and motion like human being. Is it possible?
Mm-hmm. Maybe Professor Kim, you have some of those robot demos before.
That's a great question that every soft robotics wants to pursue. So I think the current level of the technology is not as delicate as a human muscles, but still there are many attempts to reach that goal. So one way to achieve that goal is bio-hybrid robots. So usually there are people who are actually culturing the human muscles and connect those muscles with the other robotic component, so that the actuation can be accomplished just like a human muscles. But still you need some other accessories which make that kind of muscle-like motion. So, but if you can develop those kind of materials and also technologies, and also there are people who are making skins, human skin like the materials. So if you combine all those kind of ingredients of around the world, there are people who are working on that kind of thing. And eventually you'll be able to make something like that, but it'll take some time. And then in the meantime, we'll have to focus on the soft materials and also, combination of soft and rigid materials to come up with the solution to do some specific tests. But I think that's the eventual goal of all robotics these days.
Yeah, how about Professor Kramer? What do you think? The
Maybe
future of having an artificial muscle?
Yeah, maybe I can add a little bit. So there's a lot of work going on artificial muscles, and where you can construct gel-like objects which contract and expand or release the contraction upon certain stimuli. But I think there are two questions which have to be answered in this context, or solved. One is how do you get the energy into the body to do this action, like in biology, and the second one is to connect that to the nerve system, that it's steered by the nerves in the body to really have this action. And I think these interface issues are very, very delicate issues. It's known that when you have typical semiconductors and you connect them to nerve cells, that you get scars, and that you typically have to work with too high voltages in order to get signals. There are improvements coming from organic electronics, which seem to make this better. But I think that are the two points which have to be really solved to have an implant which works like a natural muscle.
Professor Tan.
I think there are two parts of this human-like robots. Right? You have the hardware, like what the gentlemen have mentioned, but there is also challenge in the software side, right? So example like those digital humans, I believe you have seen a couple of them, and you can realize that they are not real, right? And once you make this a humanoid robot, the main challenge is how do you program inside so that they can behave, they can react to you, they can have the expression like real humans. There's still a long way to go.
Thank you very much, panelists. And now it is the open talks that all of you, everyone in the audience, can deliver the questions to our panelists. So don't hesitate to raise your hands so our staff can assist you with the microphone over. So anyone with the questions to our panelists? Yes, please.
Yeah, there's a question
Yes.
back here.
Yes, maybe I have one question right over here.
Okay.
So could you please assist him with the microphone? Thank you.
Thank you. Thank you for your presentation. So what can developing country like Vietnam do to catch up with and contribute to the global robotic ecosystem from fundamental research and application testing to establishing AI safety guides? Thank you.
Yeah, so what fundamental research problems in robotics that people in a developing country like Vietnam can contribute to the global robotics research? Please, Professor.
I think for a country like Vietnam, there are a lot of talents, and even young talents. They are very eager to tackle challenging problems. And based on the projection, in fact, for the robotics, 50% of the robots market and manufacturing will happen in Asia, right? Mainly in China and some other Asian countries. So there are a lot of opportunities there. The needs, the environment, the so-called society, actually the robots which actually can live in this country are also different from other countries, other part of the world. So I think that Vietnam can actually focus on those that are more suitable to the Vietnam society or the local industry. And these are a lot of the so-called, I believe the work will be done by VinMotion.
Okay. Yeah, maybe I can try to contribute just a bit. So maybe I'm trying too hard, but I try to convince people that we need to change our perspective a bit. This is our open world, right? I would say that people don't care if we come from Vietnam or not, right? So I think the world is much more open. Most robotics paper now is open source, right? Hardware is much more affordable. Most of robotics research conference now is a kind of blind review. People don't care if you come from Vietnam or not, right? So I think there's a lot more open opportunity for robotic researchers to contribute
And even if you are in Vietnam, there are a lot of open opportunity for you to contribute. So if we can change our mindsets, don't be scared, right? Dream big and then submit paper. I think it will give you a lot of excellent opportunity in the future.
Great. I think we have a question over here. Yes, can someone bring the microphone? Yes. Can we bring a microphone? Yes. Oh, okay. Thank you.
Okay, thank you very much for your interesting and comprehensive about intelligent robotic automation. I just only focus on about the future of material for a human. You have just said that the human move from the hard material to soft material. Whether or not we go to up to the smart or maybe no material when we try to produce the robot, the first one. And the second one, I would like to know about robotics or robot automation can help people to lengthen their longevity. For example, about maybe 80 years, maybe we can live about 1,000 years, okay? Whether or not the robot can help people, can lengthen the life, okay? Longer, longevity of the people, okay? That's, I think that's the main point I focus on, okay?
Thank you.
I'm waiting for your response. Okay, thank you. Yeah.
So
yes,
any
panelists.
chance that robotic can help us to live longer? Potential, robots can extend our human longevity.
There are now robots helping humans, right, to climb faster, walk faster. Right? I think somehow this kind of assistive robot will be more and more, right, helping you, working together with you to address those demanding tasks. But the challenge is how can they understand your mind and they continue, so-called, help you to live longer. I think there is still a very interesting and long-term question. And there are work about the human and machine interface, right? And try to actually extract some kind of a thinking, the memory from human bodies. But I believe these are just the beginning of the research. There are still a lot that we need to do.
Thank you.
May I
Please.
add on that?
Yeah.
So I guess there may be many different ways that robots can contribute to longevity of a human. One is through the external, body parts of our, damaged, like through war battle or the diseases. Robots can give us, artificial arms or legs, which can, help us to move around. Also, there are, technologies working on artificial organs like heart and also, other, internal organs, which can substitute the old and diseased organs. And also, there are technologies called micro-nano robots, which we can ingest or which you can inject into our body. And for example, it can attack the cancer cells or tumors and do the treatment actively. Without the drugs, the robots can directly go into the disease site and then fight with the diseases. So that kind of thing can contribute greatly to our human longevity. But there's still more long way to go. But still, that's the way one of the our robotic technology can contribute to human society as well.
Great. With that long-term vision, I think it's the time to close our panel. Thank you, everyone, for the. Do we have another question?
Yes, thank you for your conclusion for the panel discussion. And now we're moving to the Q&A session with a lot of questions from the audience.
Yes.
Still have a lot of.
Yep.
So I see a man waving hand right behind the previous one with the previous questions.
Okay,
Yes,
so
please.
come up. Yeah.
May our staff can assist him with the microphone. Thank you.
Many thanks for the great discussion so far. So my question is, do you think the humanoid embodiment is optimal? Because as you had discussed before, like you had to, for example, the Anvu question about soft tissue in humanoid, right? How do we develop that? And it's come with a lot of like hardware and software challenge. So do you think humanoid as a mechanical system is optimal? Maybe it's converging to other embodiment like four leg, like a centaur or wheelbase, something for the industry and daily life.
Maybe Professor Nguyen, you could have an unbiased answer.
Yeah. So I think I got this question a lot. So I may have a bit of answer for this. So I normally compare the solution that we have in industrial robots because we already have that example. I would say that 80% of the application in industrial application, we would not require a 7 degree of freedom robot arm. But we still have, 7 degree of freedom robot arm as a dominant kind of solution for industrial robot. So the main reason because of this is about the scale. So I think in industrial application, sometimes if you, in a factory, right, sometimes you only need 3 degree of freedom, sometimes you only need 4. But the problem that even when you build such kind of subsystem on top of it, it still requires significant effort for you to integrate. So that is the reason why it's come from the practical requirement for manufacturing application that 7 degree of freedom robot arms seem to be what's called optimal solution for many different kind of industrial application. However, the problem is that for industrial robot arm is have kind of fixed base, right? You can only put it on the base. When people start thinking about moving kind of far away from industrial setting, that we hope to have robot moving around what we call human-centric environment. I would say that most of the time it's not an optimal solution to have humanoid. But I think in general, if you want to talk about the scaling problem, I think humanoid is a good option because for different things. When you have a humanoid robot, it's almost by default that you should be able to use as humanoid robot to mimic some tasks that human is already doing. So by design, it's mainly like you don't need to think about what should be a good solution for that. By design, you think that if you can mimic human, it's already good enough. The second thing I think is more important is that when we move toward physical AI, it's very important to have some form factor that's close to human because you mostly collect data from humans. So even sometimes the form factor of humanoid robot, let's say, can be optimal in some scenario to adapt to that application. But when we talk about long-term kind of impact of that, having human form and human life is much more easier for you to leverage a very large scale of, let's say, human data, video from the internet, and also interaction with human. I think it's also, I'm not saying that it's optimal, but I think that and go option that people want to take.
Yes, Professor Kurt Krimi, do you want to add some more information about this question?
I think, sorry. This was a fantastic technical answer. I think one can give a fairly direct and simple answer to that. If we look into biology, if we look into evolution, humans are the most versatile ones and they can do everything. But when it comes to being very fast or very strong or so, there are other creatures who are much better than us. And I think in this respect, robots probably will be kind of similar. You have specialized ones, and then you have the more general ones, where certain robots probably will be like humans from the construction, while in other cases you need different specialities. And I think biology really tells us a little bit which direction this will go, or evolution tells us.
Of course, it's just like why we want to have humanoid robot, right? Because it is easier to be accepted by the society. Right? Earlier about this longevity question, right? So why you want to rebuild the human parts, right? If today you can have a ChatGPT of Mingdo, right? He will speak exactly like you, have your memory, can advise anyone like you, so is it consider you, right? So it's a society whether they are ready to accept such form of robots.
Thank you very much, Professor Tan Yapeng. So we still have room for many more questions. Yes, please, Professor.
Hi. Okay, I have a question. I think one of the problems is how fast this field is evolving. I'm a climate modeler, and in our field, 4 years ago, AI was okay. Neural networks we've been using for a long time, whatever. And in a couple of years, everything changed. Now there are weather forecast models that are totally AI-based, even climate models, and I assume the same is in every other field. So how do you, it's very difficult to cope with something that evolves so quickly. And it's an issue of education as well. The people don't understand what's happening unless, like you're a specialist. So how do you, what's your thinking about how education should change so that people can catch up with what's happening? So if you understand it better, probably you can accept it better. Because I think, as you say, there's a lot of science fiction skepticism about what might happen. And many times it's because people don't know what's going on. So I wonder whether you have some reflections about how education might change to allow people to catch up with what's happening so fast.
Any comment on what should we do in terms of education?
Okay, this is a very tiny question. In fact, VinUniversity, we are going to have a President Innovation Forum this Saturday to talk about this topic. We have invited a couple of president provosts from overseas and local to explore this. How can we revamp our education so that our students learn the new knowledge which is ready for this AI or robots-driven society?
Actually, I was a department head until last June, so I thought about this kind of question for long. So this is ever-evolving period, especially for mechanical engineers. Actually, the mechanical engineering has not been changing very rapidly until a decade ago. But now, with the advent of the AI and physical AI, a lot of things are new things are coming up in the field of mechanical engineering as well. But even in this kind of ever-changing era, I think we need to go back to basics. With the fundamental, strong fundamental knowledge, you can cope with the ever-changing environments. But without the very strong fundamental knowledge of especially for the hardwares, you need the mechanics and understanding of materials and how things react chemically and how things change in terms of the physical environments. So you should stand on the very strong background of your major. Then you can think about how you can apply this fundamental knowledge to every changing in a field, and you can advance the current technology. So that the education, I think, need to stand on 2 feet. One is on the very strong fundamental knowledge of your discipline, and the second one is you have to teach the students or a future generation to open their minds and absorb other disciplines work without any prejudice. And also you have to teach how to interact, how to communicate with other disciplines and also people in the other fields. So that's one way to think about how we can educate other next generation.
Yeah, and also can add to that, from my department, electrical and computer engineering, we typically say that to the high schooler, like everyone wants to work with the robots until they have to work with the robots. The reason is it's so attractive, so engaging. It's a great drawer. You see the robot competition, for middle school and high school. So I think it's a great way to bring students into the field. But then once they are in the field, I think they get exposed to a number of fundamental knowledge, but also a lot about the engineering mindset. When you work with actual systems, things failed, you need to debug, think about how to fix the problems continuously, find out different ways. I think it's a great platform for training engineers, right? Problem solving, overcome, challenges and failures. So I think that's still intrinsically, and yesterday there was a discussion about AI safety. I think about educatability, right? Really this unique human attribute. And again, we can interact and use a robot to enhance our human learning experience. Yeah.
Thank you, Professor. And now I want to hear some more questions.
Yes,
the man
question
over
in front
there.
here, please.
Yes.
Yeah,
From the third
microphone
row.
is right in the middle here, please.
So here's your microphone, please.
Thank you very much, Professor, for the information that you are sharing today. So we talk a lot about manufacturing. So, but my question is I want to ask about the healthcare. So the way we care about the health is changing. We change from treatment to the active prevention. So it means the role of the caregiver, the role of the rehabilitation is more and more important. And yes, we see a lot. We don't have enough people in that field. So what do you think about the challenge that need to overcome in order for a humanoid robot to fulfill that role in the next 10 years? So thank you very much.
Yes, panelist.
Maybe Professor Kim. So what kind of robotics systems that can have for human, for healthcare in the next 10 years?
What kind of robot system will help us in terms of human healthcare?
Yeah.
So as I mentioned before, very, very important role of the robotic system is the taking care of the elderly. So, these days, the people live longer, and meaning that the period that we need other people's help is getting longer and longer as we get old. So, and it's a big problem in Korea as well. So, we need people we need young people who will take care of the old people. So we need, so old people cannot move, freely, so that we have to help them to move, and also you have to feed them, and also you have to take care of the drugs and those kind of medical treatments. So in that case, we need very many large numbers of robots which can substitute those kind of, helpers. So that is the very important the area where a robot can contribute, in addition to the human health, but also the social welfare. So that's a very important problem that can solve the social problem of the aging society. And also, as I mentioned before, there is a very, very active research for the micro nano robotics, which can treat your tumors, cancers, or any blood vessel clogging, that kind of problem. That can be working inside our body, so it can revolutionize the future medicine. So those kind of things can be considered as the very actively researched areas in robotics for human health.
Yes, Professor Tan.
Of course, certainly I think this is a very important question. And just like the education, right? And to support the so-called humans so that they are more healthy, both physically and emotionally, right? And there are two parts of it. Okay, we can have those service robots or taking care of elderly, and those jobs that normally many people prefer not to do. But there are also digital companion, right? And even before you become ill or emotionally, and then what are the things that this kind of chatbot can help you, right? To talk to you. And there are now digital companions that some countries actually rely heavily on, which become unhealthy, ethical issue. But these are things that are going to exist, going to develop further. So how can we actually make that happen that is helping us to live longer or study better, become the companion that is become our advisor, like Mengdo, right? Become our advisor to do research, to do things, right? And that is possible. It's going to happen, just in what kind of format that the society is ready to accept it.
Thank you very much, Professor Tan Yapeng. Ladies and gentlemen, because of limited time, so with the last questions, I will our symposium today is coming to an end. We are so sorry, but don't worry, we still have breakout sessions where the scientists and the audience can network and connect with each other. We have 3 rooms with 3 assigned topics. So right now, everyone can join together. One more time, thank you very much, our audience, and especially our panelists. Thank you for your informative presentation and active participation on our symposium discussion. We really appreciate that. And ladies and gentlemen, don't forget to follow us in VinFuture Prize Award ceremony will be live broadcast in VTV1 December the 5th. Goodbye for now and see you this afternoon. Thank you, panelists. Thank you very much. We love you all.